Hey there, welcome back. I think today is a kit day. So this is a die rolling kit that I got on eBay for a buck something probably. And the only problem with this kit is there was missing parts. There was actually all these 10K resistors were missing. They only supplied one. So some of my resistors will be added to this and they won't match, but that's not that big of a deal. So I think first of all we should start by putting in the resistors because they're the lowest profile. And here's where I've been making an effort for all the older electronics enthusiasts watching. I've been learning my color values. So we'll start over here. We have three 470 ohm resistors, and that is 470. Let's see if I can get it the right way around because the colors aren't very obvious here. But I know purple is 7, and brown is times 10, and I think yellow is 4. Yeah, 7 times 10, 470 ohms. So I'm going to set these into, I think there's 3, yeah, 470 here. $470 here. And another 470. I'm sure there was 3. Oh, right there. 470, 470, 470. And this is going to be using my good old lead solder. It's just a whole lot easier to work with. And as long as you don't eat it and you wash your hands, no danger whatsoever. Tip of my iron might be actually a little too large for this. Yeah, got a bunch of ugly solder blobs on there. That's okay. It's also worked better in a PCB vise. But I don't really have one yet. I will get one. When is up for debate, but I will get one. Cut all these legs off. Okay. 470 ohms soldered. Whoops, I forgot my auxiliary lighting. There we go. Should be a bit better. Okay, 470 is done. Now, this one here is orange, orange, green. Orange is 3, so it's 3, 3, and then green is 100K, so 3.3 meg, I believe that is. It's 3.3 meg over here, only one of these. Okay. This guy here is yellow, which is 4, purple, which is 7, and green, which is times 100K, so 4.7 meg down there. One, two. Get a third one in here. Brown, black, red. So brown is 1, black is 0, and red is times 100. That's a 1K. So this is my only 1K. I have to put a bunch of 1Ks, so I'm going to skip that one. Brown, black, blue. So again, 1, 0. And it's times 1 meg. So 10 megohms. Right here. I actually prefer the 5-band to this 4-band color code, but that's alright. Get used to it. Okay, chop these off. Okay, and oh, I only have one more resistor really, which is this guy here, brown black, so 1 0, and then orange, which is a 1K multiplier, so this is a 10K. You know, I don't think you need to learn the color codes to do electronics. I think if you do enough of it, it'll come to you. Like if you, you know, every time you take a look at them, you get to see the pattern, you know, brown, black, 1 0. I think green is 5. I'm not looking at my I have a chart nearby, so I don't know my multipliers by heart. But, yeah. Okay. So, next lowest profile components are the 4017, which I believe is a shift register. Don't quote me on that. And then the 555 timer, which is a 555 timer. Gonna set these in. I don't know if they'll actually hold together while I attempt to solder them. And if you can't get the ICs in, you just kind of have to rock them on a solid surface like this to line up the pins. I went too far on that one. I'm rushing a little bit, I'm trying to make this a not so long video. My shorter videos tend to do better, which I assume means that you guys prefer shorter videos. I try not to babble on too much. There we go. These ICs are well set into place. I can go ahead and solder the rest of the pins. Should be in shot. Yeah, I think so. Building kits is fun. I think I'm going to make videos sort of trying out the, trying to reverse engineer these circuits. If you're experienced at electronics, these circuits are nothing magical to you. You probably know them by heart, how they work. But not me. I'm still learning this stuff. Okay, I think I should get those 10K resistors now. So I have one 10K resistor. Oh, am I missing a 1K? Uh-oh, did I install something in the wrong place? So a 1K would be brown black, which is 10, and then we need 2 more zeros. So brown black red. Did I put a brown black red? That's brown black orange. Nope. Oh, this is a 1K. This was not a 10K. I see. So they just didn't give me any of the 10Ks in the kit. There we go. That's an easy fix. Okay, I guess I should go get those 10Ks now. Okay, 10K ohm. And these are quarter watts. I believe these might actually be a little bit smaller. So how many do I need? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. So 8. I'm going to chop them off the bandolier. 1 and 2. There's 8 of them. And this is a 5-band color code. So you got brown, black, black, and then brown, which would be times 10. So is this 1K? What am I doing here? Brown, black, black. That's 100 times 10. Yeah, 1K, right? That doesn't make sense. Oh no, it's red. 100. Okay. So it's brown, black, black, red, and then the tolerance band. Gotcha. Okay, I'm gonna chop these off. Alright, get rid of those bandoliers. So I was kind of discouraged when I saw I was missing pieces on this one, but then it's just resistors, really. And I guess if I would have known beforehand, I could have opened a complaint with the seller. But really, it doesn't matter that much. It's still only a few cents worth of resistors. Just kind of sucks when you get amped up to make a video and then you see you got missing pieces. I hope this kit works too. Would kind of be sucky if it didn't. But I guess if it doesn't work, then we can troubleshoot. I'm not an expert at troubleshooting, but what makes you an expert is doing it. So just do it until it becomes second nature. I wonder why they're using transistors here. I feel as though if you run the LEDs dim enough, you can just run them straight from the shift register. But, you know, I'm no expert. And just because you can do something doesn't mean you should. Oh, I'm starting to see cross-eyed here. Components are so small. Surprisingly, I feel like I have less trouble soldering surface mount sometimes. Because surface mount, although it's small, it's meant to be small, and I guess my focal plane is all the way down onto the board instead of up on these legs. Oops. Nailed my iron there. There you go, and I got that one already. There we go. All the resistors put in. Oh, that one jumped up a little. That's okay. Okay, now we've got 5 transistors, which is quite a few actually. They seem to go this way, and they will stay in place just by jamming them in, because it kind of spreads the legs a little bit. I know it might stress the legs of the component a little. These are all the same transistor. They're 8050s. Not sure if they're NPN or PNP, but we can follow the pins to figure it out. Alright, give that a solder. I dropped the temperature of my iron a little bit. I usually solder around 350. I went down to 330, and I'm not liking it. It's taking a bit longer to transfer the heat through. That's way better. Whoops. Little solder bridge there. Oh, solved. Good. You shouldn't cut 3 pins at a time, but I do. If I was selling components, like if I was selling boards pre-soldered, I would take way more care. But for the moment, at least until I actually physically break one, I think I'm going to keep going the way I do it. So now the switch. So the switch is a little bit more complex. I'm not sure if it goes this way or this way. Actually, it seems like they're asymmetrical. So I do think it goes this way. So let's put that in. There we go. Switch is done. Put in the caps. 104. It's 10 nano. Like that. And then the electrolytic. This kit, they actually gave me 2 electrolytics, but you only use 1. Here we go. And the switch. Okay, all that's left now is the connector and some LEDs. Now the LEDs have a flat spot on the negative side, shorter leg there, flat spot here. It looks like they go this way. Ooh, they're a nice fit in there. Can I prove that it's negative? Not really. But it looks like it from the symbol there, so I'm going to assume it's right. Hopefully not blow this thing up. Those holes are quite tight. And then all that will be left is to solder the connector, and that'll be it. It's really hard to, when the board is not secured, ouch, got hit by flux. It's really hard to press down enough to get a good heat transfer going. And that's why I find those helping hands are okay in some situations, but not in others, because they don't let you really press down hard. A vise is much better for that. Might end up with a pen of ice or something. We will see. Come on. Okay, now just a connector left. Which I'm not sure which side is positive and which is negative. Oh, there, it's actually written there. Perfect. This one obviously doesn't fit now because I didn't go by the highest to lowest profile. So I'm looking for some sticky tack. Here's some, but it's all dried up. I just have to revitalize it. Okay, shove this guy onto there. Not sure what voltage this is supposed to be run at, but I feel as though 9 volts will work. There we go. Alright, this is all finished. The only thing left to do is test it. Put your bets in the comment below. Will it work or will it not? Do you trust my soldering? Do you trust my reading of resistor values? Oh well, do you trust that my resistors are all, my LEDs are all crooked? Maybe I'll fix those. Put it in the comments below. What do you think will happen? Will this work or will it fail? Hopefully all your bets are in the comments below, because now it's time to try this thing. So I have the positive on this side of the plug, so it'll be like this, the wire with these red lines in it. Plug that in. I don't actually know the working voltage of this, so this can be quite interesting. But I'm assuming, because as a 555 timer, 9 volts probably going to be okay. There we go. This is all set up. Okay, so 9 volts. I also have a 200 milliamp, 229 milliamp current limit, so if it goes wrong, it shouldn't go wrong too spectacularly, but here it goes. Oh, okay, so it starts up, we've got actually a number here. We've got 3. It's interesting that's 1, 2, 3 like this, and not this way, but that's okay. Let's give this a... Oh, something went wrong. Constant voltage, 12 milliamps. Okay. Oh boy, it's interesting. So, it doesn't work. Let's try to figure out what went wrong here. So I'm going to bring you in a little bit closer. We're just going to check the solder, see if everything went well there.